Hello everyone, my name is Bing Yu and I'm a postdoc at UC Berkeley. Today I will walk you through the day 5 of our Python exercise, which is about data handling. If you follow the link on your B course, you will be directed to this page. Now click this button to open our exercise. When it is ready, click the copy to drive so that you will be able to save your changes. Okay, let's get started. In your research and work, you will possibly find that you are frequently dealing with a variety of data input formats, and among them, the tabular formats such as the CSV files and the Microsoft Excel files, as well as the semi-structured Json files and XML files are among the most frequently used file formats. You possibly know how to deal with them already in Excel, MATLAB, or even text editor. And today we can show that you will be able to do lots of similar things in Python. First, let's download some of the data sets that we'll be using. So the data we use include 2 CSV files and 1 OpenStreetMap OSM files. The extension is OSM, but it is in JSON format. Let's wait for it to finish. Okay, now the downloading has finished. We can go to the file directory and refresh it, and you will be able to see these files that we have just downloaded. And there are lots of outputs here. I don't want to see them, so I can click Edit, clear all outputs, and now it looks cleaner. In the first part of this exercise, we'll deal with this tabular data format. Some of the examples include the CSV files and the Microsoft Excel files. So for example, here is a small example of the CSV files that is similar to what we'll be using. You can see that there are 3 rows and 5 columns. If we view each row in the file as a record, we can see that different rows have the same attributes, including ID, name, direction, start intersection, and end intersection. So what does it mean? So the row 1 means that this is a data entry for Hearst Avenue, the road segment going from east to west to the west direction. The start intersection is at La Loma Avenue and the end intersection is at Oxford Street. Now let's try to see this on Google Maps. So it is Hearst Avenue. And so for those of you who has not come to Berkeley yet, Hearst Avenue is the one that is on the north side of the campus. And the civil engineering building is around here. So the first data entry is Hearst Avenue east to west from La Loma Avenue to Oxford Street. So this is La Loma Avenue, this is Oxford Street. So east to west, this is the first record. The second one is still Hearst Avenue from west to east, start from Oxford Street and ends at La Loma Avenue, which is from this direction to this direction. So it's a convention in traffic analysis that for two-way roads, we will represent them as 2 separate entries. And the third row is Euclid Avenue from south to north, starting from Hearst Avenue and ends at Marine Avenue. It's a long stretch of Euclid Avenue, start from here, ends at Marine Avenue. Oops, this is Marine Avenue. Okay, so now this is what CSV files look like. Now let's read the data that we'll be using. Specifically, we'll use a Python tool called Pandas, short for panel data analysis. We'll first import it using import pandas as PD. And then we want to read the CSV files, and we know the name of the file is Hearst Euclid. So let's read it into a variable called df, short for data frame. The function is df equals to pd.read CSV, a bracket, and inside it we'll give it the file name, which is Hearst Euclid.csv. And then we can print the first few lines of the data using the head command. Okay, so now this is what our data looks like. So by putting different values here, we can control how many rows we want to print. If we don't put anything here, then it will give us 5 rows. Okay, so the data seems pretty simple. So some information about Hearst Avenue, the eastward direction, starting node and end node, and starting node and end node is different. So the Hearst Avenue is really long, so we break them down into small segments, and each will have different start and end node ID. Next, we want to do some basic explorations of it, and specifically, we want to know how many rows are there in the CSV file, and what are the unique row names that are contained in this file. So let's do it in this way. We want to print the number of rows and columns. So the data frame object that we just created, the data frame object has this shape attribute, which we can access it, use .shap.shape. Okay, and let's see what's the outcome. Okay, so it tells me that the data has 41 rows and 4 columns. Feel free to download this data to your local computer and play with it and see if it is accurate. And the df shape, the shape attribute actually gives us a tuple where the first element is the number of rows and the second element is the number of columns. If we just want to know the number of rows, we can do number of rows is df shape 0, which will give us the first element. But if we just want to know the number of columns, we can do df shape get element 1, which will print the second element. This is because in Python, it's zero-based index. Let's see if it is accurate. So we see there are 4 columns here. The first one is index and is usually not a separate column. So there are 4 columns in the data frame. And next, we want to print the unique names, the unique row names in the data. To do that, we can use the df. We want to get the row names. We select the column, row name. And we want all the unique values. We can use unique function here. Okay, so the data is pretty simple. We only have information about Hearst Avenue and Euclid Avenue, which are 2 important streets on the north side of the campus. Okay, so here we briefly showed how to select just one column. We can also do more complex selections based on the location and some criteria, and we'll show each of them. The first one is to select the first row. So we have this df variable. If we want to select the first row, we can do df.ilog, the location, 0. Let's see what's the output. Okay, so it tells us for the first row, the start node ID is 119 and node ID is 172. Is Hearst Avenue eastward? This is the same as what we see here. We can also do like this, comma 1, which will print in a nicer format. The difference is that if we don't put comma 1, then it will give us a Pandas series. But if we do comma 1, it will give us a data frame. So personally, I prefer to work with data frame, even though the result is only 1D, but you feel free to choose whatever that works for you. And now we want to select the 10th row. And remember that in Python, the index is 0-based. So if we want the 10th row, we want to put the index 9. Okay, so this is our 10th row. We can also get the data frame by putting a 9, 10. So this is the 10th row, but the ID of the 10th row is 9. Comma 10 means that 9, 10 means that we want to select the rows that start from ID 9 and ends at ID 10. We only include the first one, but the 10th one is not included. The last one is not included. Okay, so now let's try to select the first column in the first row. This is a cell value. We just want to know one cell. So we can do df.ilog, give it a coordinate, first row, first column, just for reference here. And you can see that, oops, sorry, I made a mistake. First row, first column. Yeah, now it's correct. The first row of the first column is 119. So how about the next exercise? We want to select the 10th row of the column row name. So we can do df. We want to get the row name column only and the 10th row. And you can see, indeed, we got this Hearst Avenue. We can also do some more complex selection, such as select all records with the row name equals to Euclid Avenue and print only the first 2 rows. So let's select a data frame where the road name equals to Euclid Avenue. And we only want the first 2 rows, right? Let's see what's the outcome. Okay, so these are 2 rows of the records that has the name Euclid Avenue. To see if it's correct, you can download the data and open in Excel and check. So what does this mean? So log is selection based on some criteria, and inside is the filtering criteria. Now, if we only print the inside of this log function, we will see that it actually gives us an array of binary variables, where the number of rows, number of items in this array of series equals to the number of rows in the data frame. And it will return like a binary result of whether the condition is met for each row. Because we know that for this file, it starts with Hearst Avenue. So for the first few rows, the results are all false. And then for the last part, the results are all true. And this log function basically only keeps those rows whose values are true. And then the last exercise on indexing, we want to select a subset of columns that is shown here and print the first 2 rows. We can do df and select we know how to select only one row. If we want to select only one row, only one column, we can just do a column name. But now we are selecting a list of column names. So we need to give them in a list, making a total of 2 square brackets. And then we copy the column names here and print only 2. Only 2 rows. Let's see the result. Okay, so now you can see that I'm only printing these columns. Another useful thing to do with Pandas is to loop through the data row by row. You can do many things if you know how to loop through the data. There are different ways to do this iteration through each row, and some of them are not very efficient, some are more efficient. And if you are really good at it, you may also use You may also use NumPy to do vectorization, which is much more efficient than most looping. However, for beginners and also for this course, just using conventional looping method is enough. If you want to know more, there are lots of resources online to help you with finding the most efficient method. And specifically for this exercise, we want to loop through each row and create a new column called road and direction. And this road and direction column will combine the first letter of the road name column and direction column. So for example, if we have a new column here, then for this row, the new column value will be HE. And the next one is also HE because it combines the first letter of these 2 columns. To do that, let's first create an empty list because we don't want to give the value to the data frame when we are iterating through it. And then we can iterate through this data frame using this itertuples method. This is my personal favorite because I find it to be really versatile and efficient. But as I said before, there are lots of different ways to do that. So now we are in this for loop. For each row, we want to get the first letter of the road name column. So we can use this get attribute function, and the first argument is the row, and the second argument is the column name. Because we only want the first letter, so we will index it with a 0. And then the next one, we want to get the first letter of the directions column. It's mostly the same, except from now the column name becomes direction. And then we want to combine them together using r plus underscore plus d. And because r is a string, there's a string, you can connect the strings with the plus sign. And then next we append this new value to the empty list that we have created. Because we know that the data has 41 rows, so after this iteration process, the list will also have 41 elements. So we can assign the list to a new column. And then we can randomly print a few rows to see if the result is what we expect. Yeah, indeed, you see that the new column is created and it is formed by the first letter of the road name column and the directions column. All look okay. In our next exercise, we will show you how to merge the information into Pandas data frames. As you can see here, this is the data frame that we have just created in our previous exercise. It doesn't hold a lot of information, but we want to know more about the roads here. For example, what is the length of the road, what's the number of lanes, and what's the speed limit. We provide this additional information in another file called berkeleyedges.csv, and here are some example rows. In fact, this new data file is a lot larger than our original data frame because it contains the information of all rows in North Berkeley. In addition, we also know that in these two data frames, there are some common set of attributes such as start node ID and end node ID. And when the start node ID and the end node IDs are the same across the data frames, they are referring to the same row segments, like the first rows in each of them. And what we want to do is to give this additional information to our original data frame. If you know SQL, then possibly you also know that we can do this through a join command. In Python, you can also do the same. Python provides 4 types of joins, including inner join, outer join, left, and right join. Regardless of the type of joins, a join operation will increase the number of columns in the final data frame. But the type of join will determine the number of rows in the final data frame. So let's take this left join as an example. In this left join, there are 2 input data frames. The one that comes first is called the left data frame, and the ones that comes the second is called the right data frame. A left join will keep all the rows in the left data frame, but only keep the information on the right data frame if it already exists in the left data frame. And in our case, this works the best because our left data frame is really small. It only contains the information of 2 rows, while the right data frame contains the information of many other rows that we are not interested in. So we will do a left join to only keep the information that is related to those 2 rows. We can do it in Python here. First, we need to read in this second data frame using this pandas read CSV command, and then select a few rows to display the content of it. So we can see that it has a lot more columns than the data frame that we are working with before. Before we go further, let's spend some more time in knowing the information in the second data frame. For example, what is the number of rows and columns in it? We can do it, use this shape attribute. And it tells us that the second data frame that we have has more than 800 rows and 12 columns, while previously the small data frame that we have only has about 40 rows and 4 or 5 columns. And also we notice that one of the column is called start OSM ID. And the OSM is short for OpenStreetMap. This is the ID of the start node used by the OpenStreetMap. We can locate it easily by going to this URL. So the URL of OpenStreetMap /node and then the node ID. Let's copy this. And then try to see it in OpenStreetMap. So this is the start node of our first record. And similarly, we can locate most of the other elements in a similar manner. Okay, now let's merge the information contained in the second data frame to our original data frame. We want to use Pandas Merge function, the name of the first data frame, then the name of the second data frame. The type of merge is left. Common set of attributes include start node ID and end node ID. So this should give us what we want, but let's just double check the shape of the new data frame and also display a few rows in it. Okay, we can see that the merged data frame has 41 rows, the same as our left data frame. And here are the first 2 rows of it. It contains the original information, but also some additional information. What about a right join? So if we do a right join, Then the shape of the resulted data frame is a lot larger because it's keeping all the rows in this second data frame. We are not really interested in that, so let's change it back to left join. Okay, so now we can do more things with it, such as counting the total length of the road of Hearst Avenue. We can do this through this grouping operation. So the resulting data frame is called df expand. We want to know the total length of road of Hearst Avenue and Euclid Avenue separately. We will use this group by operation and group by road name. And then aggregate the length attribute by taking the sum of it. Okay, so now that's the total length of each road. We can also do other types of group by, for example, counting the number of road segments or the number of records for each road name and directionality. Group by, we'll group by 2 columns, so we'll use square brackets to put them together. Group by road name and direction. And use a size function to get the number of records in each group. Yeah, and you can see that for Euclid Avenue northward, there are 12 segments. Euclid Avenue southward, 12 segments. And that's the same for Hearst Avenue. But this doesn't look very good, and this column doesn't have a name, so we'll just use additional function called toFrame to convert it into a data frame and give it a name called segment count. So here is the result. The last thing that we want to introduce about the CSV files is how to save the results. We can do this use the toCSV function. We just need to give it the name of the output file, and if we are not interested in keeping the index, we can give it an option called index is equals to false, and then execute it, refresh the files, and you can see that this newly created file. You can download it and play with it on your own computer to see if it's what you expect. The second part of today's exercise is to work with semi-structured data, such as JSON or XML. So this is also a common type of data inputs. For example, the raw output of OpenStreetMap is in this kind of format. And here is a snippet of the data that I have downloaded before from OpenStreetMap. It includes version information, generator information, and some other things. The full dataset is provided in a file directory and is called target northberkeley.osm. We can load this data into Python using the standard JSON library. We can do it via JSON load open file name. So this OSM data should have everything in this data file. And let's find out what is inside it. So first, we want to see what is the type of this OSM data object. OSM data, we want to know the type of it. And you can see that it is a Python dictionary. Okay, so we know Python dictionary because we know that it has keys and values. So we want to print the all the keys. So there are 4 keys in it, including version, generator, OSM3S, and elements. So what is under these keys? Let's try with version. So OSM data, access the dictionary value via the key. The key is version. Okay, so the value is very simple, it's just 0.6. And then we can do the same for other keys as well. But I have played with this data before, so I know that these elements contains the most important information. And let's first check what is the type of this result. Okay, so the OSM data under the elements key, it holds a list. So for list, we want to know what is the length of it. Okay, the list has 6,781 elements. Why not just print out some elements and then see what's inside it? We want to print the first element and the last element. Okay, so the results are shown here. The first element is a short one. It is a node that has a certain ID and coordinates. The last element is a long one. It is a way or something like a road link, has another ID and the nodes that form the road link. It also has some other additional information. For example, here we know that it is a residential road that is shared with bike. The maximum speed is 25 miles per hour, the name of the street, and some other things. Okay, so it seems like there are lots of data contained in this OSM data object. And one thing that we possibly want to do is to separate the information in it into the node information and link information. We can do it through a for loop. So first, let's create this all nodes dictionary to hold the information of the node elements. And the print OSM data elements 0 will give us an example node. Okay, so this is our example node, and we want to keep the information, the ID, and the coordinates. So let's look through this OSM data. For each element in OSM data elements, if the element type equals to node. If element type is node, then okay, that's what we are interested in. We will add it to our dictionary. The key should be element ID. And the value, we want to keep the values of the coordinates, which should be element longitude and element latitude. Okay, so we can check the total number of nodes in our OSM data by simply counting the number of dictionary items. Let's run it and see the outcome. Okay, so we know that the OSM data contains 6,187 nodes. In total, there are less than 7,000 elements, and most of them seem to be road nodes. And let's do the same thing for the road links. For each element in the OSM data elements, if the type is way, then we know that it's a link element. We want to add it to our dictionary using our links element ID as the key, and the value should be what value we want to keep. We want to keep the category and the nodes that form the link. So the categories can be found under tags, highway, And the nodes can be found just using this nodes key. So element X highway, and the second piece of information is element nodes. And we can count the number of total way elements in the OSM data by counting the number of elements in this all links dictionary. Okay, so the whole data set only includes less than 600 roadways. We can save the result, the separated nodes and links information, using the Json Dump function. So we'll dump the dictionary to an out file with certain indent format. Just execute this cell and then refresh your files, and you'll be able to see these newly generated files. You can download them into your computer and then see if the results are what you expect. Okay, so that marks the end of today's exercise. Hope you will find them useful. Thank you very much.